Hi, PreCalculus. Welcome to section 5.4 notes. We are doing sum and difference identities. So we've got 6 different identities. And these are when you've got two angles. So like this is cosine of alpha plus beta, where alpha is some angle and beta is some angle, and we add them together. Then we could split this guy up and form this big identity here. So why is this ever useful to us? So if you look at example 1, it says find the exact value of each trigonometric expression. So sine of 15 degrees. What's the problem with that? It's not on the unit circle, so we don't know the exact value for it. And you could say, well, we can just plug it into a calculator. Well, plugging into a calculator doesn't give us the exact value. It gives us a decimal approximation. An exact value would have like square roots in it and fractions, and it's going to be ugly, but it is the exact value of it. So what we want to do is think about our unit circle and find numbers that we could add or subtract to get to 15. So think about the angles we have on our unit circle. We've got 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and then plus 90 to each of those guys until we get all the way around to 2 pi, or to 360 degrees. So looking at these guys, if I wanted to come up with two angles that add or subtract to 15, well, 45 minus 30 would be 15. Or you could say 60 minus 45 is 15. It doesn't matter which one you want. You just need to find one of them. So I'm going to do, in fact, I'm going to make it over here. Sine 15 is the same thing as sine 45 minus 30. If you choose 60 and 45, you'll still come up with 15 degrees too, and you'll still get the right answer. So this is sine, and I'm taking my angles and subtracting them. So when I look for my correct identity, I want to find the one that's sine. So that's going to be this row here, where it's sine and sine. But since I'm subtracting my angle measures, I want this guy here, where we are subtracting the angle measures. And notice this column is where we're adding the angles together. This column is where we're subtracting the angles. And then this row is cosine, sine, and then tan. So we're going to plug into this one. It's going to be sine of the first angle, cosine of the second angle, minus cosine of the first angle, sine of the second angle. And again, that's just using this identity here to stretch it out. So how did that help us? Well, we know what sine of 45 is, and cosine of 45 is, and cosine of 30, and sine of 30. So now we can figure out what that exact value is. So sine of 45 degrees, I want to know what's the y value at 45 degrees. That's square root of 2 over 2. And cosine of 30 degrees, that's my x value at 30 degrees. That is square root of 3 over 2. Minus cosine of 45 degrees, again, that's x at 45 square root of 2 over 2. Sine of 30 degrees is 1 over 2. And so multiplying this out, square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4. Square root of 2 times 1 is square root of 2. 2 times 2 is 4. If we want to get real fancy, we could put this all over one fraction, because we have a common denominator. All right, same thing for B, except for B we're in radian measure, and so this gets a little bit trickier because we've got fractions. And so one way to think about it is you're looking for two numbers that multiply to get to the bottom one, add up to get to the top one. So two numbers that multiply to get to 12 and add up to get to 7 would be 4 and 3. And so instead of being pi over 4, this would be 3 pi over 4, 4 pi. Oh my gosh, nope, just kidding. That's pi over 4, pi over 3. Sorry, it was a long weekend. Pi over 4, pi over 3. Okay, wait, Miss Harris, how did you get that? What did you do? All right, so if you notice, 3 times 4 gives me 12, 3 plus 4 gives me 7. So what happens when we actually add these? Why does this work? Well, if we were to add these two fractions, we'd need a common denominator, which would be 12. And what would we do here? 4 times 3 gives me 12, so this would be 3 pi. 3 times 4 gives me 12, so this would be 4 pi. When we add them together, 3 pi plus 4 pi gives us 7 pi over 12, which is our common denominator. So that's why it works. But how you find is look for two numbers that multiply to give you this, and then either add or subtract to give you the numerator. All right, once we know our two angle measures, then it's just a matter of plugging it into the identity. So here, I want the tangent identity where we are adding the angles. So tangent identity where we are adding the angles would be this guy here. So this is going to be tangent of pi over 4 plus tangent of pi over 3 divided by 1 minus tangent pi over 4 times tangent pi over 3. All right. Then we're going to go back to that unit circle that we have memorized up in our noggin. What is tangent of pi over 4? At pi over 4, y is the square root of 2 over 2 divided by x, which is the square root of 2 over 2, and that would just be 1 plus, all right, pi over 3, what's your y value? It would be 1 over 2. Nope, just kidding. That would be for pi over 6. It would be square root of 3 over 2. What's your x value? 1 over 2. Get this out of the way. I get less confusing if I can get it to erase. When you're dividing fractions, you want to multiply by the reciprocal of this guy. When we do that, what happens to our 2's? They cancel out, and we're just left with square root of 3. All right. On the bottom, I've got 1 minus tangent pi over 4 we said was 1. Tangent pi over 3 is 3. 1 times square root of 3 is square root of 3. Now, can I leave it like that? Nope. We've got a radical in the denominator, so we're going to multiply times the conjugate. Big vocabulary word, conjugate. All right, 1 times 1 is 1. And then I've got the square root of 3 plus the square root of 3. That's going to be 2 square roots of 3. Square root of 3 times square root of 3 would be 3. On the denominator, since they're conjugates, the middle terms are going to cancel out. 1 times 1 is 1, minus square root of 3 times square root of 3 is 3. Woo. And then we get 3 plus 1 on top is 4 plus 2 square root of 3. 1 minus this 3 is negative 2. And now 2 is in all three of these terms, so I can cancel them out. 2 goes into 4 2 times, into 2 1 time. Don't forget, you got that negative still down there. And so this finally would boil down to negative 2 minus square root of 3. All right, let's look at the U try. Cosine 15 degrees. Again, that would be cosine of 45 minus 30. You can do 60 minus 45 or some other variation of that. All right, if we are subtracting our cosines, our identity is cosine 45, cosine 30, minus sine 45, sine 30. Cosine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. This time it's minus. Sine is square root of 2 over 2. Sine 30 is 1 over 2. And we end up with square root of 6 over 4 minus square root of 2 over 4. All under one fraction or over one fraction would look like that. For B, we're looking for two numbers that multiply to 12 and add up to 5. And we don't come up with anything, right? There's 6 times 2. There is 12 and 1 and 3 and 4. None of those add up to 5. So let's see if we multiply it by 2. Can we come up with two numbers that multiply to 24 and add up to 5? We came up with in class pi over 4 and pi over 6. What happens when you multiply or add these guys together? What would be your common denominator? They both go into 12. All right, 4 times what gave you 12? That was 3, so this would be 3 pi. 6 times what gives you 12? That would be 2, so this is 2 pi. And then 3 pi plus 2 pi gives you your 5 pi. That is not the only one. You could also end up, let's see, I think I did it in one class. We did 2 pi over 3 minus pi over 4. And in another class we did pi over 3, I think it was 3 pi over 4 minus pi over 3. Could be wrong. But I'm just saying that there's different ones that you could do. You don't always have to do one that's addition. You could also think about ones that are subtraction. And then one strategy, if the fractions are really, you're struggling with that, think of a way to rewrite them as a fraction that you know, and then try splitting it up that way. So 5 pi over 12, I'm trying to say 5 pi over 12. Convert this guy into degrees. So we know there's 180 degrees per pi. These guys cancel. And then 5 times 180 divided by 12, I don't know off the top of my head. So 5 times 180 divided by 12 would be 75 degrees. All right, can you come up with 2 angles that add up to 75 from our list? How about 45 and 30? All right, and then 45 degrees. Once you know what they are in degrees, then convert it back to fractions. This would be pi over 4. This guy would be pi over 6. And that's another way to end up where we were here. So one strategy, like I said, one strategy is take your angle, convert it into degrees, find your 2 degrees, and then rewrite them in radical, or not radical form, help me out, with radian, put them in radian form again, and then work your problem this way. I do want to see your problem worked out in radians though. So it's cool to use degrees to figure out which ones you want, but then work the problem actually in radians itself. All right, so then since it's sine of an angle plus an angle, our formula for this one is sine cosine plus cosine sine. Where did I get that from? From the top of this page in the chart. All right, sine of pi over 2 is square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2. Square root of 2 over 2. Cosine of pi over 6 is 1 over 2. Are they always going to end up being square root of 6 plus square root of 2 plus or minus there over 4? No, just these ones that we've been working with ended up being the same. All right. That is it for problem number 1. Come back and I'll have example number 2.